Hello guys, welcome to Ekraft. So today we are gonna learn about antennas. So what is an antenna? An antenna is a metallic object, mostly a wire or group of wires, or we can say poles, which is used to convert high range frequencies into electromagnetic waves. These converted waves can be transmitted and received through an antenna over the air. What's the use of an antenna? Why do we use it? The main use of antenna is not only to send signals within the area which it covers. The main objective is the signals that can be reproduced again and again with minimum losses of signal or distortion. So why do a transmission needs less distortion and minimal loss? Basically, when we transmit a signal to the receiver end, the data encoded in the signal has to be received properly. But if there is some distortion, the data sent may not be properly received. For example, when you are talking to someone on call, because of some transmission problems, we face distortion in voice. Hence, we need less distortion or signal loss while transmitting and receiving signals. So, what is the working principle of an antenna? It works on the principle of electromagnetic waves, which are commonly known as EM waves. So, let us understand some basics of EM waves. So, this is the graphical representation of electromagnetic waves. According to the diagram showed in the last slide, electromagnetic waves are energy which are transmitted or propagated in the free space at the speed of light. So basically, these waves are synchronized oscillations of electric or magnetic fields that propagate at the speed of light in free space. So, for understanding the fundamentals of EM wave, let us visualize an example that you are standing on a bridge and dropping a stone into water. As the stone travels downwards into the water body, there is a path of air bubbles generated in the same direction, and there is a ripple pattern spreading horizontally across the surface of water body. So these ripple patterns are here representing electromagnetic radiation pattern. The falling stone is representing direction of wave, and the bubbles generated are representing electric field. So this was all about the fundamental concept of electromagnetic wave. So now we got a new term, radiation pattern. So what is a radiation pattern? A radiation pattern is nothing but a pattern which provides us the information about transmitting and receiving behavior in all possible directions of an antenna. Every antenna has a different type of radiation pattern. Even there are some antennas which provide three-dimensional radiation patterns. So let's talk about the types of antennas. There are two main types of antennas: resonant antennas and non-resonant antennas. The resonant antennas transmit signals in almost all directions. Hence, they are also known as omnidirectional antennas. One of the most popular examples of resonant antennas is Yagi-Uda antenna. The non-resonant antennas transmit signals in only one direction. Hence, they are also known as unidirectional antennas. One of the popular examples of non-resonant antennas is rhombic antennas.